Take a look at this, example 8. What is the reduced radical form of this product? So, again, based on structure. The last structure we saw a distributive property structure, a single object times multiple objects. Now we have a binomial times a binomial structure. We have several ways of doing that. The one we most commonly use is FOIL, right? So if we do FOIL on this, the first times the first is going to be 2x times 2x, which is going to be 4x squared. The outer times the outer, positive 2x times positive square root of 3 makes positive 2x times the square root of 3. Inner times inner, negative square root of 3 times positive 2x makes negative 2x times the square root of 3. And last times last, negative square root of 3 times positive square root of 3 makes negative square root of 3 times 3. Okay, just like I did last problem, instead of multiplying the 3 and 3 together, I'm going to break it apart. Looking at the 4 objects, look at the black object first. I have a pair of 3's inside a square root. Again, this is understood to be a second root. I got a pair, so I get to pull 1 3 out for the pair in. And everything inside's gone, right? So that means the radical is no more. The square roots, it would have been square root of 9, which equals 3. That also would have been fine. But again, sometimes they're not as friendly numbers as these. The other thing we might notice, this has a square root of 3 and this has a square root of 3. Also, they have an x and an x. So the radicals have to match, but also if there's letters involved, the letters have to match to be like terms. So these two guys here are like terms. The numbers don't matter for like terms, only the letters if there are letters and radicals if there are radicals. Since x squared of 3 and x squared of 3 match, this is legally allowed to add or subtract. 2 minus 2 makes 0, which means that they cancel. And that is a likelihood in these problems, that sometimes things cancel. So what we're left with altogether, after we do all this product, is this term, which is positive 4x squared, and this term, which is minus 3. And all the radical stuff disappeared, and we're left with this nice, friendly 4x squared minus 3 answer. Again, stop there. Don't try and do anything else to make it look any prettier. More than one object is finding a final answer in Algebra 2. So don't try and subtract 3 from 4x squared. You can't do it.